Welcome to Down Ancient Trails, the online archaeology forum of the Sharma Center for Heritage Education, India. Brush the dust off long forgotten thoughts. Slice through time and space.
Listen to stories in stone.
Whispers of voices lost in time.
Build bridges across worlds.
Curious minds reach out to the past. And travel down ancient trails.
Great. Okay, thank you very much indeed. I really appreciate the invitation and a very kind introduction. And it's so nice to be here today. I'm actually in sunny Greece at the moment. I've been here since the middle of March, escaping COVID situations. But I hope everybody who's watching this is in a safe and happy place, and that one day soon we're able to meet up in more fortunate circumstances. As Shanti said, I'm going to talk today about aspects of Neanderthal and modern human interaction, and particularly the dating side of things. Now, for those of you that aren't perhaps so up to date with, as it were, with what the human story is over this period of this last 100,000 years, let's say, well, the situation is rather like this. We know that our ancestry is ultimately from Africa, and we know that over the course of hundreds of thousands of years, if not millions of years, successive waves of hominins left Africa and moved out into the so-called Old World of Eurasia. And so far as modern humans are concerned, anatomically modern humans, Homo sapiens, Homo sapiens sapiens, however you want to describe them, we think that that our ancestors evolved in Africa between about 250 to 300,000 years ago. But there's no magical single moment when that process becomes apparent. Instead, we have degrees of gradation of modern human ancestry in Africa. But we know that at some point, it could have been as early as 170,000 years ago, but certainly by 50 to 60,000 years ago, humans had left Africa, and they had moved, some of them had left Africa and moved into the wider expanses of the Old World. And there, some of the most intriguing interactions took place between our ancestors and archaic or earlier humans, predominantly Neanderthals and Denisovans, who had been living in these areas for several hundreds of thousands of years, but ultimately shared a common ancestry with us. And so you can see by this very useful map that Roberts and Stewart produced in 2018 that we anticipate the pathways of modern humans as they moved into these areas down through the south, along the south coastal route perhaps, and towards the subcontinent and into Southeast Asia and Australia. Perhaps another group going northwards into the northern parts of Siberia, and ultimately into Europe. And it is mainly focusing on Europe that I'm going to be looking at in this particular talk. And that's because in Europe we have, well, I personally have done quite a lot of work, but also we have a very long history of archaeological excavations that have been taking place over the last century and a half. So my area of interest is in chronology, and in this particular illustration, you can see the challenge of radiocarbon dating. This is a picture that shows it like stars in the sky, around 10,000 carbon-14 atoms, and it shows how over time the radiocarbon decays exponentially. And as it does, it reduces substantially the numbers of measurable atoms of carbon-14 that a scientist like me can measure in the lab. So from 10,000, every 5,500 years, half of that 10,000 atoms is registered. And so by the time we get back to the period of Neanderthals and modern humans, we're down to 100 atoms of those original 10,000 or less. In fact, by the time we get to 40,000, we're back to 0.7% of the atoms of carbon-14 that we had at the beginning. And this means that small amounts of contamination can be extremely influential unless they're properly removed. If we can't remove contaminating forms of carbon, then we can get dates that are significantly underestimating. So, for example, if we had a date of a true sample that was 50,000 years of age and 1% of it was contaminating carbon of a modern age, get a date that was almost 10,000 years too young. And so for this reason, scientists working in radiocarbon labs dating Neanderthals and early modern humans have had a very tough job to remove all of the contaminating carbon and to ensure that the dates we obtain are reliable. So for most of the last 25 years, I've been working on ways in which to improve the radiocarbon dating of very ancient samples. And we have now developed a series of what we call pre-mysteries, just a way of saying how we sample using chemical method. And so for the three main sample types that we date in the Paleolithic, that is bone, charcoal, and shell, we have three very, we think, very reliable techniques now that we use routinely to prepare the sample for measurement. Ultrafiltration of bone is something I'm going to talk about in a second. A method called ABOX-SC, that stands for acid-base oxidation stepped combustion of charcoal. This is a method that we use to date charcoal to clean the charcoal very effectively to provide improved radiocarbon dates. And CARDS is a method of carbonate density separation to remove contaminating forms of calcium carbonate from marine and estuarine and lacustrine shell prior to radiocarbon dating, which has also been shown to be a very reliable method. And so we've established a series of methods that we think are reliable and in terms of giving us improved dates for the Paleolithic. Let me just briefly introduce the ultrafiltration method. So bone is about 80% a mineral cement called hydroxyapatite, and 20% of it is protein. And it just turns out that that 20% is what we want to focus on for reliable dates. And so first in our lab, what we do is we take a dental drill and we drill a small amount of bone powder from the bone. And then using an acid, hydrochloric acid, a dilute acid, we undertake a process of decalcification. And that simply means we use the acid to remove the hydroxyapatite component. And that leaves us with raw collagen. You can see floating around in the bottom of this test tube. And then we undertake a process called gelatinization. And that takes the collagen, which is a series of triple helixes all wrapped together in a single shape like that. And it undoes them. It brings them into solution. It's rather like when we make jelly, same process is taking place. And that gives us this gelatinization process, that gives us this improved collagen, this purified collagen. But it still contains contaminants that we want to remove. And so the next step is to use this thing, which is an ultrafilter. It's about 7 or 8 centimeters high. And it can be thought of rather like a sieve, a molecular sieve. Now we know that the single parts of the collagen, these single polypeptide chains, they weigh between 95 to 102,000 daltons. And so what we do is we use a molecular weight cutoff filter, like this ultrafilter, which traps material that is 30,000 daltons or more above the level of the filter. We put the bone gelatin into it. It traps the bigger particles like this above the level of the filter and enables us to separate them from smaller contaminating types of carbon. And this way, it improves the cleaning, the pretreatment of the bone collagen that we date. And these methods have been described in these publications in the journal Radiocarbon. Now, the next stage of the radiocarbon process is the same for every sample. It's accelerator mass spectrometry. And so we take that sample of collagen and we put it into a series of very small little tin capsules and we burn them, we combust them, we convert them into carbon dioxide and then into graphite. And the graphite you can see here in this image on the lower right-hand side with these very small aluminium targets. The graphite is placed in the top of one of those. And then it's measured up here on the top right in our Accelerator mass spectrometer, which is a newly installed AMS that we obtained and started to run at the beginning of 2019. Now, I want to now describe why this process of ultrafiltration is initially so important. And I want to give you an example of why it is important with reference to a very important archaeological site in Italy called Fumane Cave. And as you can see from the top map, the site of Fumane is in the Venetian region, in the pre-Alps. And it's an archaeological site that's been excavated by our colleagues Marco Perezzani for many years. And we first got interested in the site back in around 2008 because we wanted to test some of these newer methods and see if we obtained different radiocarbon dates. Many dates had already been obtained from this archaeological site, which spans the Mousterian, Neanderthals, all the way up through the Ultrafiltration, Proto-Aurignacian, Gravetta, and that's the period of modern humans. And you can see from the diagram, we have around 40 radiocarbon dates plotted on this illustration, and most of them fall around this 40,000 year line. That's 40,000 years ago in red. And to the right-hand side, it's younger. So a lot of these radiocarbon dates that you can see here fall younger than 40,000 years ago. So what we did was we selected some samples from previously dated specimens that had been dated in our lab, and we radiocarbon dated them using either ABOX methods or ultrafiltration methods. And what we found were quite significant differences between the earlier dates that had been obtained with less reliable methods and the new chronology which had been obtained using these improved methods. Here's an illustration showing you the latest series of dates we had from the site. Now this is 40,000 years, this line here down the middle, and you can see that almost all of the dates that are from the Neanderthal Mousterian, the industry called the Proto-Aurignacian, they all fall to the left of 40,000 years ago. Most of the dates previous to that were all younger than 40,000 years ago. So we calculated in 2011 that 75% of the previous radiocarbon dates were unreliable. They were wrong. They were too young. And this, we explain, is because of unremoved contamination. So ultrafiltration and ABOX together, in this particular illustration, you can see that the red dates here, the ones in red are ultrafilter dates, and the ones in black are ABOX dates. Very consistent together, all the way through from the bottom of the site down here, all the way to the top of the site. In this so-called Bayesian model, all of the dates make sense for the first time. They're not scattered and they're not too young. So we were very excited by these types of breakthroughs and keen to extend the work to other sites. As you can imagine, we wanted to get the dates right. And so we wanted to look at questions like, when did Neanderthals disappear? When did the earliest modern humans arrive? And so we began to work on many sites using these techniques to see whether we could understand more about the precision and the accuracy of the dates of the transition from the Middle to Upper Paleolithic and the disappearance of Neanderthals. Now in 2006, there were several radiocarbon dates of Neanderthals that had been dated directly, which were very young. So in this diagram, which comes from Delson and Havati's summary paper in 2006, you can see that some dates from sites down here in the south of Spain, for example, are less than 30,000 years old. And others from sites in, for example, at sites like Vindia Cave in Croatia, Mezmaiskaya in Russia, and other sites in France, estimated to be between 30 to 35,000 years ago. So, as you can imagine from our previous experience at sites like Fumane, we were quite suspicious about these latest estimated dates from some of these sites. And so we decided to approach some of the archaeologists working at these places to see whether we could redate some of the specimens and redate some of the sites and the archaeology. One of the sites that I mentioned in the previous slide is this site of Zafaraya, a really important site because it has a lot of Neanderthal bones in it. It's a very large cave site near the city of Malaga. You can see here a very large cave. These are people down here to give you a size of the scale, an estimate of the scale. And over the last 40 years or so, Many Neanderthal remains have been excavated from the site, and they've been radiocarbon dated by association. That means that we date bones that are nearby to the specimens, and using techniques like radiocarbon and uranium series, a series of dates were obtained from Zapharia, which suggested that the Zapharia Neanderthals were extremely late surviving Neanderthals. In fact, the radiocarbon dates that were initially produced dated to between 33 and around 29,000 radiocarbon years ago. That's about 33 to 34,000 years ago. Surprising to many, because, of course, we thought that Neanderthals disappeared a lot earlier than that, but seemingly here in the south of Spain, they survived later. But did they? So my student Rachel Wood obtained some sample from previously dated specimens that we dated in our laboratory. So here's a sample of bone that was previously dated at 33,300 plus or minus 1,200 years ago. And we redated this, and we got dates using ultrafiltration of the same bone that were more than around 47,000 years ago. A huge difference, more than 15,000 years difference. But the incredibly significant of small amounts of contamination, these two bone dates are almost certainly reliable compared to this. This one is contaminated with something. It hasn't been removed with the pre-treatment method. Whereas these bones are greater than ages. That means the true age is beyond 47,000 years ago. We also dated material from below the Neanderthal bones, and we also got dates that were much, much older than we thought possible before, suggesting that the Neanderthals from this site didn't date to 30 to 34,000 years ago at all. They dated more than the radiocarbon age limit, probably more than 50,000 years ago instead. This was published in 2013 in PNAS. We subsequently worked on on 40 sites, and we obtained 500 radiocarbon dates over the course of about 6 years, of which 200 dates relate specifically to Neanderthals and Neanderthal cultural occupation in the form of the Mousterian and sites distributions called the Châtelperronian, which are in Franco-Cantabria. And so using all of these new data, we were able to try to calculate the latest appearance dates for Neanderthals in these various sites. And we restricted the sites to sample places where we had a number of radiocarbon dates. So this slide summarizes the distribution. And what you can see here are a series of little probability distributions that correspond to different archaeological sites in Iberia, Western and Northern Europe, and Southern and Eastern Europe. And so these distributions represent the latest possible dates for the Mousterian at these sites. Once again, I'll draw your attention to this line here on the right-hand side, which is 40,000 years ago. You can immediately see that all of the dates are older than 40,000 years, not younger. So we were able to, using Bayesian statistical modeling, to produce a final date estimate for all of these sites and all of these 200 radiocarbon dates. And we calculated that the last Mousterian took place between 41 to 39,000 years ago, and that's at 95% probability. In other words, there's a 1 in 20 chance that the true age will be later than or younger than that estimate. So it's a pretty robust estimate if you're a gambling person. This suggested to us that the Mousterian ended by this date. We also dated sites from an industry called the Châtelperronian, which has been linked with Neanderthals because of evidence obtained at 2 significant archaeological sites in France. We obtained several radiocarbon dated sites, and we modeled the distribution of the start and the end of the Châtelperronian, and you can see that in the bottom diagram here. We estimated that the start of this Neanderthal Châtelperronian industry took place at around 45,000 years ago, and it ended at almost exactly the same period as the Mousterian ended at around 40,000 years ago. And we also looked at another industry in Italy and in Greece called the Ultrafiltration, but I'm going to talk a little bit later. So in summary, the results that we obtained back in 2014 suggested that Neanderthal sites end at around 41 to 39,000 years ago, that there was variability in the age of the final Mousterian. It ended in different parts of Europe at different times. And also, we were able to calculate an overlap period by looking at the dates for the earliest modern humans in Europe and the final Neanderthals, and we calculated that there was an overlap in such a way that for 2,500 to 5,500 years, modern humans and Neanderthals were both in Europe at the same time. By this, we don't mean that they were living side by side, although we cannot be sure of that. We think it's more likely that they were in the region of one another, perhaps. But I'm going to talk more about this at the end of my talk. I was surprised by this. My hunch at the beginning was rather like in the work of other people, that when modern humans arrived, Neanderthals disappeared quite soon after. I didn't expect to have such a degree of overlap between the two groups, but that's what we find, that's what our data suggested, and that's what we published. Now, it turns out that ultrafiltration, whilst very useful, sometimes doesn't remove all of the contamination. This is for two main reasons. The first is that contaminants can be of a high molecular weight, and that means that if we use an ultrafilter, instead of filtering the contamination away, we'll actually trap the contaminant above the level of the ultrafilter, and we will inadvertently date it. Instead of being removed, we date it, and that means that it can produce dates that are unrealistically wrong. This we think is a quite rare occurrence, but it does happen mostly when we have bone that has been treated in a museum using glues or conservation products that have a high molecular weight. The other possibility is that because bone that is ancient tends to break up and to degrade, a lot of that material just goes through the ultrafilter, and we end up having nothing to date. So there are two potential problems with ultrafiltration. But we have been working on developing new methods to radiocarbon date samples of bone which remove all contaminants, and there is no debate regarding this. And this is a method called single amino acid dating. This is my colleague Thibaut Deviers, who's been working on this as part of my team for the last 5 years, building on the work of others previously in our lab. And we have developed and almost perfected a method now of extracting a single amino acid from the bone that we radiocarbon date. And this we use a technique called high-performance liquid chromatography. Very briefly, what this involves is the use of chromatographic methods. When we use these chromatographic methods, people who have done sort of first-year chemistry and school chemistry might remember doing this using gravity as the mechanism by which you separate different analytical materials. So, for example, here is a nice example where you've got 3 colors that together form black. So it's blue, yellow, and red. And when we put this into the chromatograph system, we can see that they separate from one another based on the way that they react to what we call the stationary phase. This is this column, which is packed often with silica-based products. And it allows us to separate different components of a previous whole. Nowadays, we use high-performance liquid chromatography, which uses high pressure to make the job much quicker instead of relying on gravity. And so this relies on a mixture of a mobile phase, which is the material that carries in this case, the amino acids through the HPLC system, and the stationary phase, which you can see here. So what we do is we inject the mobile phase, it gets pumped at high pressure through the stationary phase here, and then we inject samples of the bone collagen that have been broken up into single amino acids, of which there are 24 in collagen. And these amino acids are then separated using this HPLC system, and then detected and collected using ultraviolet methods. And so we can then collect single amino acids from the bone collagen, thereby eliminating contamination. Here's how it works when we are looking at on the screen. The sample is injected. And then you can see the amino acids starting to appear over time. And the one we're really interested in is hydroxyproline, or HYPE. And this is the one here you can see coming off the column very quickly. It comes off, it came off our system rather early, which is encouraging because it's the one we really want. And hydroxyproline is an attractive amino acid because it's around 10% of the total carbon in the bone. And it's also very restricted to mammalian collagen. So if we take hydroxyproline out of a bone, we can be very, very sure that it's likely only come from the bone, not from anywhere else. And it's possible using this separation method to date a sample without any contamination whatsoever. Now, excited by these developments, we've applied these compound-specific or single amino acid methods to archaeological cases. And the first one I'd like to share with you is the site of Vindija Cave in Croatia, which you might remember from a previous slide, was one of the very latest dated Neanderthals. In fact, our laboratory has dated this sample back in the 1990s to around 29,000 plus or minus 400 years BP. And this is a small piece of a mandible fragment from a Neanderthal from this very important Croatian site. Another piece of bone from the same site, this time a parietal cranial fragment, was dated to almost exactly the same date in our lab back in the 90s. And these samples have stuck around for many, many years. Some people argue that they're real, that they mean that it's alive late. Others, like me, were suspicious. We were suspicious because of the problems with contamination. And so in 2006, I obtained a tiny amount of remaining collagen from our laboratory, and I ultrafiltered that once again. And you can see here that the dates that we originally got, these dates here, these gelatin dates, the first series of dates, we redated them using ultrafiltration. We got dates that were several thousand years older. And here too, in the second sample, we got the same situation. But we were suspicious that there might still be unremoved contamination because of various hints and indications in the laboratory. So for that reason, when I published this paper in 2006, I said that these dates were a minimum age and probably older, but they weren't as young as 28,000 or 29,000 years old. They were probably 32,000, 32,500 or older. So a couple of years ago, we got the opportunity to take more material and to use HPLC systems to redate the sample using hydroxyproline. And you can see those results here in the green lines. So the same bone that gave us the 28,000, 29,000, 32,000, when we redated it using hydroxyproline, it gave a date that was almost 10,000 years older, suggesting quite nicely that the original bones were contaminated with something we think probably museum-based. The second bone gave us another date that was older by another substantial amount, around 10,000 years or more. And the last example that you can see, which shows the challenge of these radiocarbon dates of old samples, shows what happens when we use ultrafiltration to date a bone that hasn't been conserved in a museum and a date with hydroxyproline. You can see we get the same date, get the same result for those because that bone wasn't treated in a conservation laboratory, whereas the other two were. So for the first time, we've managed to show that these Vindija Neanderthals were much older than we thought before, and not, rather like in the Zafaria case, not as young as once suggested. Another site that I just want to quickly give you a final example from is the site of Spee. And in the diagram I showed you, in which we calculated the last appearance of Neanderthals, you can see it was one of the latest dates, the latest distributions of ages that we got. Spee is a very important site. It's in Belgium, and it's a site that was the second location in Belgium to produce Neanderthal remains. The first was Angis. Very early excavations in the 1850s, though, produced the remains of 3 Neanderthals in toto, but later work by colleagues in Belgium has added significantly to that original collection. Of the 89 hominin bone fragments that were excavated originally, more than 1,800 have now been added by further investigations. And this is a very much ongoing work. We were interested to see, rather like the Vendia case, SPE was also underestimating the real age and whether or not we could push back the dates for Neanderthal disappearance. And so we were able to.
Tom, I think we've lost you. No, it's okay. It's okay? Okay.
Mandibular and a maxilla, and with the teeth still preserved. And so the arrows point to the two samples that we were able to radiocarbon date, a sample from the maxilla and a sample from the lower molar. Filter dates here coded with AF with hydroxyproline dates. You can see the dates are in very close agreement with one another, suggesting here that there is no contamination of significance at that site. If there were contaminants, then maybe we would see a different story. If some of the bones had been treated with glues and conservation product, again, maybe we'd see a difference, but we don't in this case, suggesting that there is no contamination at that particular site. Now I just want to briefly turn to the evidence for the earliest humans in Europe, the earliest Homo sapiens. Because of course, what we're interested in is knowing what happened when Neanderthals and modern humans met. And for that reason, we have to know not only the latest Neanderthals, but also the earliest modern humans to see how much they overlapped by. So when we look at early humans in Europe, a very significant discovery took place in 2011 at a site in the very southern part of Italy, in a site called Cavallo cave. Shown here with this arrow, it was excavated since the 1960s, and the remains of some personal ornaments were discovered, which you can see in the bottom right-hand side. Some perforated shells were the most common ornaments. There were also bone tools and bone points. And, as you can see on the left-hand side, some human teeth. Now, initially, these human teeth were identified as probably being Neanderthals. And so the industry from which this site comes, and this material comes, called the Ultrafiltration, after the Bay of Abruzzo in the southern part of Italy, the Ultrafiltration industry was formerly called a Neanderthal industry. However, two significant pieces of information, new data, came together in 2011 to show that this was not the case. On the right-hand side, you can see the results of an analysis of the shape of the teeth from Cavallo cave, undertaken by Stefano Benazzi and colleagues. And what you can see here on this principal components analysis is the distribution on the top there of modern humans with the black dots and Neanderthals on the left-hand side with the triangles. And the Cavallo tooth, in this case Cavallo B, falls bang in the middle of the modern human distribution. In the bottom, the distribution is the same. The modern humans contain the distribution of Cavallo, the other Cavallo tooth. And this suggested that the Cavallo humans weren't Neanderthals, they were modern humans. On the left-hand side is the result of some radiocarbon work that was done by Katerina Duca of the Oxford lab, which showed, very interestingly, that the Ultrafiltration deposits in Cavallo cave were very ancient indeed. In fact, we estimated the start to be around 45,000 years ago. We couldn't date the earliest of these levels, but you can see that the start of stratum E, which is towards the base, is almost, it overlaps with 45,000 years ago. And so this publication in 2011 argued that the earliest evidence for modern humans was coming out at around 45,000 years ago in Italy, and it was the Ultrafiltration. cave. This was published in Nature. Some of you may have seen earlier this year that this evidence was backed up and corroborated with discoveries at the Baccio site in Bulgaria. Baccio site that's been excavated again very long time ago, produced a lot of very interesting evidence, including some human remains that unfortunately were lost, but new material was discovered, new human bones were found, and new radiocarbon dates were obtained for a very important archaeological layer dating to the initial Upper Paleolithic. Human bones were found that were directly dated. The archaeological evidence is shown on some of it is shown on the left-hand side, ornaments, points, bone polishes or lissoirs, and so on. And as you can see on the right-hand side, the archaeological site and the dates that were produced, a huge number of very well put together radiocarbon dates, almost exactly mirrors the dates of the earliest evidence from the Ultrafiltration at Cavallo, around 45,000 years ago. This means that modern humans were present in at least Eastern and Central Europe by this date. We have also very important information that bears on the case of Neanderthal and modern human interaction from a site in Romania called the Peștera Cuoasei, where a very interesting modern human maxilla mandible was found, I should say. Mandible was found on the right-hand side by cavers in this, group of cave sites in this location. We radiocarbon dated that bone in our lab, and it came out at exactly the same dates as the disappearance dates of Neanderthals that I mentioned earlier, between 41 and 39,000 years ago. But in 2015, very significant evidence was found that supported an initial assessment of the physical anthropology of that specimen that showed that it had had a Neanderthal in the recent family. It had been interbreeding with a Neanderthal. This male had a Neanderthal 4 to 6 generations back. In fact, this slide shows that rather nicely. You can see here, these are this is a picture showing the DNA of intergress Neanderthals in groups of archaeological bones from different chromosomes in the genome. So in these chromosomes, you can see the top line here with the letter O and the green lines. These are just DNA intergressed from a Neanderthal into the bone of that Oase individual. And what it shows is very large tracts of Neanderthal DNA in the ancestry, recent ancestry of this individual. So as I say, this suggests that this person had a Neanderthal and that interbreeding had been going on 4 to 6 generations before he lived. And so this gives us very nicely, I think, a latest possible date for Neanderthals that is in very close agreement with the dates that we've already obtained from the latest Neanderthals. Now, very finally, I'd just like to share with you how we can visualize this in terms of a spatio-temporal model. It's possible using Oxcal, the software that we use to do our modeling and calibration, to look at time slices through the last few thousand years to see where modern humans and where Neanderthal dates fit and where they sit. And so what I'm going to show you now is a series of slides which have a series of data points on them. The blues in this case correspond with the Mousterian Neanderthal tradition of stone tool technologies. The red will be the Chattelperronian. Again, these are Neanderthals. And the green and the yellow, in this case, are the Ultrafiltration and the Aurignacian, which are also modern humans. And I've also added just now the date here for Baccio for the modern human dates that I just told you about. So here at 45,000, you can see we've got predominantly Neanderthal Mousterian in the west of Europe, but we also have the Ultrafiltration site at Cavallo and at Baccio. We also have presence on the periphery, it appears, of modern humans. And then going through to 44,000, we have the appearance now of Chattelperronian sites in France, and also early Aurignacian sites along the Danube corridor at sites like Geisenkloster. By 43,000, we have a situation where you can see more of the Châtelperronian sites are now appearing in France. These dots are proportional to probability. So the larger the dot, the higher the confidence, and the smaller the dot, the lower the confidence. 42,000 years ago, more Châtelperronian sites, more Aurignacian sites. 41,000 years ago, only in the northern part of Europe in Spee Cave do we have some evidence for reptiles, so I've just described. And then by 40,000 years ago, it's only anatomically modern humans. So the course of the transition, as we see it, takes place between 45,000 to 39,000 years ago. Now, this is interesting, isn't it? Because, as I said before, previously, many people thought that Neanderthals disappeared, replaced modern human arrival rather quickly. Evidence that we gained says that that's not the case. Additional evidence from archaeological research and archaeological analysis has suggested that Neanderthals have been rather unfairly treated in terms of their capabilities and their cultural attributes and behavior. And I've shown here a series of images that come from recent discoveries and recent analyses of sites, mainly in Western and Central Europe, which attest to the fact that Neanderthals, far from being the incapable people that we thought previously, were actually producing a range of complex artifact objects, including symbolically and behaviorally latent ones. They may well have been producing rock art. The evidence from sites in Spain, at sites like Ardales Cave, for example, suggests that way before modern humans arrived, Neanderthals appear to have been drawing on the surfaces of cave walls. At Runikel Cave, on the top left, you can see evidence for structural production of structures inside deep cave systems. This is about 200 meters inside a cave, and it dates to more than 150,000 years ago. At Gorham's Cave on Gibraltar, we've got evidence for images being produced on cave walls. We have a range of other types of objects and artifacts that have been produced by Neanderthals before, seemingly, the arrival of modern humans. And so I think what we're seeing is a much more complex relationship between Neanderthals and modern humans, perhaps by dint of the fact that they were present in low numbers across the face of Europe and wider Eurasia. Perhaps this meant that they were able to survive alongside one another for much longer than we thought, and maybe over this period exchange ideas with one another and interact with one another in a way that we hadn't anticipated before. It's clear that we have a lot more work to do to understand more of the nature of these interactions and how people lived together. But it's clear from the archaeological evidence that we've obtained so far that it was something that happened over a long duration, and it could even be that it was longer than 5,000 years. Nothing surprises me in the Paleolithic world. It wouldn't surprise me if there were several more thousand years of overlap between modern humans and Neanderthals, at least in this part of the world. So to conclude, just to go over the main points, what we've shown in our work is that there appear to be no Neanderthal sites in Europe after around 40,000 years ago. We also see that there's variation in the age of these final Mousterian sites. In some parts of Europe, the Mousterian and Neanderthal seem to be later than in others. We've shown that the transitional industries, these are very important archaeological industries that demonstrate the precursor to the Upper Paleolithic. We've shown that these industries, attributed to both Neanderthals and modern humans, begin and end at about the same time. We've also evidence that has been produced by other people. The Aurignacian, which is an industry that is strongly associated with modern humans, also predates essentially 42 to 43,000 years ago. And that we have modern humans in the periphery of Europe and in moving into Central Europe by 45,000 years ago, resulting in a long period of overlap between the two groups and a complexity in the relationships between the two groups that further work will elucidate more about. In the final minutes, I'd like to acknowledge my colleague Thibaut de Villers, who's worked very closely with me and my team over the last 5 years to develop further this very exciting method of reliable dating of bone single amino acids. My research partner and wife, Karina Duca, who I work with very closely and collaborate with on all of this work. All of the team of the Paleochron project, which is an ERC-funded research team that has worked on these questions for the last 6 years. Our colleagues in Germany, Max Planck Institute, all of the staff at the Oxford Radiocarbon Accelerator unit, and all of those institutions for funding. And I'd also like to thank you for listening to me and coming out to hear this Zoom lecture. Thank you very much.